Hello guys, and welcome back to a new video. Today's video is going to be on U-Substitution. U-Substitution is a form of making integration with more complex values more simple. Okay, so for our first equation today, we have the indefinite integral 4x times x squared plus 5 to the third dx. Okay, so to integrate this, we need to first assign a u value, like always in U-Substitution. In U-Substitution, you usually set the u value to whatever's in the brackets. In this case, x squared plus 5. So that means that we're going to set u equal to x squared plus 5. Okay, next step. We need to find the derivative of u, as this will give us du equals derivative of u dx. So this is going to equal the du, derivative of u, is going to equal 2x dx. Great. So now we need to isolate this dx right here. The way we're going to do this is dividing both sides of the equation by 2x. Okay, so let's go ahead and do this. Du over 2x equals dx. Great. Now we can plug this into here. So this equation now, after we've changed it, is going to look like this. The indefinite integral 4x u cubed du over 2x. Now, you might see here that the 4x as a numerator, as it is 4x over 1, can actually correspond with the 2x as the denominator. The way they correspond is by this. So 4x divided by 2x is equal to 2, as 2 times 2x is 4x. So this means that 2 times the integral of u cubed du is going to be equal to the integral of 4x u cubed du over 2x. Great. So now we can go ahead and take the antiderivative of u cubed, as we have the whole expression in terms of u. Okay, so 2 times u to the 4th over 4. Great. Now we're just going to plug in u again. So u is x squared plus 5. So this is 2 times x squared plus 5 over 4. Sorry. Great. But here, if we want to make this more simple, we can do it like this. 1 over 4 x to the 4th plus 5. Not x to the 4th, x to the 2nd to the 4th plus c. But then you might see this. You will see this here. And you might think, hang on a minute, we can do 2 over 4. So that's what we're going to do. Because this 2 here is just equal to 2 over 1, and it's multiplying. So 2 times 1 equals 2, so 2. And then 1 times 4 is 4. So just 2 over 4, which we can simplify 2 over 4 to 1 over 2. So now we can write this as 1 over 2 x squared plus 5 to the 4th plus c. And that is how we solve this equation using U-substitution. Okay, this is our second problem. You can have a go at it if you want, if you know how to do these, and you're welcome to always just go ahead in my videos and use them as practice if you want. But I'll show you, for the people who don't know how to do this, how to do it. Okay, so first we'll want to assign a u value, and as we usually make it the things in the brackets, we can see what's in the brackets here. The things in the brackets here is 2 plus x to the 4th. Great. So now we're going to set that to u. U equals 2 plus x to the 4th. Okay, so we have our u value. Now we need our du so we can find the dx. So du is going to be equal to the derivative of u being 2 plus x to the 4th. So the derivative of 2 plus x to the 4th, 2 is a constant, so that is 0. So 0 plus, and then x to the 4th. X to the 4th, if we use this, x to the n equals, and then if we want to find the derivative of x to the n, this is going to be n x n minus 1. Okay, so if we apply that same rule for x to the 4th, this is going to equal 4x and then 4 minus 1, or 3. Great. So now we know the derivative of u. So let's write that in. Just gonna clean this up real quick. Okay, so the derivative of u is going to be 4x cubed dx. Great. So now we want to isolate dx so we can put it into our equation. Okay, so this we need to divide by 4x cubed. So this is going to be du over 4x cubed. And this is going to equal dx. Great. So now we're going to plug our u and du over 4x cubed into this equation. So the indefinite integral of x cubed over u squared du over 4x cubed. Okay, so as you might be able to see already, the x cubed and x cubed both cancel out nicely, and so this becomes the integral 1 over u to the 2nd du over 4. Okay, so we can move this 4 on the bottom to the front here. So this is going to equal 1 over 4 integral of 1 over u squared du. So this is going to equal here 1 over 4, and then we can actually move this u squared back up to the top and make it a negative exponent rather than a positive. So this is going to become u to the negative 2 du. Great. Now for the integral part of it, we can just apply our power rule, or the antiderivative. So say we have x to the n. So the antiderivative is going to equal x to the n plus 1 over n plus 1. So if we apply that same rule for u to the negative 2, and then we take the antiderivative of it, this is going to equal u to the negative 2 plus 1 over negative 2 plus 1, or negative 1 and negative 1. Okay, so that is a really bad drawing of a u, I'm sorry. U to the negative 1. Great, so we'll put that in here. 1 over 4 u to the negative 1 over negative 1. Great. So we can actually move the u back down to the bottom as to make the exponent positive again. So this is going to equal 1 over 4, 1 over negative 1 u. Great. So we'll simplify this a bit more and go 1 over 4, and then negative 1 over u. And then we can't forget the plus c's on these. That's a very important thing to remember. Plus c. So then we multiply the 1 and 1's and 4 and u's. So this is going to equal negative 1 over 4u. So this is plus c. So this is going to equal, well, we'll just remember how earlier we set u equal to 2 plus x to the 4th. We're going to put that back in for u now. So this is going to equal negative 1 over 4 times by 2 plus x to the 4th. Plus c. So this is going to be our final answer. Thank you for watching today's video. I hope you enjoyed and learned a bit more about U-Substitution, or learned how to do it for the first time. And in the next video, I'll probably do integrating partial fractions. So see you next time. Bye.